Welcome to this next lesson on transitioning from SOLIDWORKS to Fusion 360 surface modelling. To create a freeform surface in SOLIDWORKS, you will typically be used to sketching a set of 2D or 3D splines or profiles, then creating or splitting a surface with these profiles using tools such as lofted or boundary surface. Fusion 360 also has the same surfacing capabilities located under the Surfaces tab, although we call the SOLIDWORKS field surface command as patch and knitting as stitching. You can also enable 3D sketches in the pop-up dialog box, then use the control points to put these into position. Fusion 360's added benefit is that it also utilises T-spline surfacing technology, a more organic approach to help speed up and simplify your surface modelling process, which you will find under the Solid tab using the Create Form command. When surface modelling, the first thing you may do is attach an image or reference photo to base your design off of. In SOLIDWORKS, you would have used a drop-down menu to find the Sketch Picture command, then follow the process from there. In Fusion, you go to the Insert drop-down and select Canvas. Choose a plane or face and select your image. Once here, we can manipulate the size to fit our pre-existing dot components. Notice you have the option to set the opacity or select see-through, which lets you work on the solid model and have visibility of your image at the same time. Once we press OK, our reference image is in position, which you can also see in the browser tree. I'll show you how we would make this lamp using more traditional surface modelling techniques, then again using T-spline technology to emphasise the differences and benefits between each method. With surface modelling, one example would be to create your 2D or 3D sketches, making use of constraints at the same time, then make a surface profile using any number of surface modelling features, as I'm doing so here with the main body. Then, I might create a construction plane and sketch another profile, then loft the two, being sure to set my curvature and its strength and any guardrails if applicable. I would repeat the above process and edit the design as necessary until we have our general form, then stitch the surfaces together, allowing me to further remove any unwanted surfaces until we are happy with the result. As you can see, all actions are captured in the timeline, meaning we can go back and edit any features should we wish. I'll undo this and now show you the power behind T-splines by creating the same model, and I'll start by bringing in a primitive from the toolbar to start to form our base design. Here I'm going to select a cylinder, as I think this will be best suited to shape into our lamp. To edit your vertices, edges or faces, select those you wish to amend and either right click and select Edit Form, or click on Edit Form from the toolbar. Then you can start to drag to match your canvas image until you have your basic outline. First I'll apply a symmetry or mirror in SOLIDWORKS between two faces from the drop down, meaning I can work on one half of the design and the change will be equally reflected. There's one quick tip here, where if you double click on an edge it will select all connected loops, something I use frequently. I'll finish creating the base of our design while showing you the options that appear in the Edit Form pop-up dialog box. The first is where you select the T-spline entity, how you want to transform the entity, the coordinate space you want to refer to, and if you want to select specific entities, i.e. vertex, edge, face, or all. The next section is where you can apply soft modifications, which allow you to select and control vertices near the selection, the influence they are subjected to, and the shape of the affected region. Your selection options helps you to easily make a specific selection, for instance a loop or ring selection. If you hover over these commands, you can also see their respective shortcut key. Here you can also see the display mode. This is something I use frequently, as it helps you easily establish its base form before subdivisions are applied, meaning you can quickly see if there are any irregularities or discrepancies in your design. Another quick tip here is you can extend a face by selecting it then press Alt and dragging away. Here I've deleted some faces from our handle, and now I want to use the bridge command to fill the gaps, available in the drop down menu or via the shortcut key. Then I can select the respective faces and use the edit form command to amend as necessary. At the very top of the light handle, I'll use the fill hole command in the modify drop down menu. When filling a hole, you have three options. The first, reduce star, creates a face using a minimum amount of star points. Collapsing places all vertices to a central point, and in this case, a fill star creates a single face with star points at each vertex, which is most suited for when you want minimal distortion. I'll do this again at the bottom, however this time I'll use the maintain crease edge option, which avoids a smooth transition. We can then carry on editing our form. I also want to tighten up the base here, so in this case, I'll insert an edge to create more control points. Then edit the design to suit. I can even add a solid modelling feature to a sculpted body, as shown here with the fillet command, meaning you're not limited to surfacing commands in your design. These solid features are also captured in the timeline, meaning I can revisit them at a later date should I need to make any changes. Finally, I'll show you how you can use sketches and the split body command to create separate bodies using non-destructive techniques. I've prepared a couple of sketches, so I'll open the split body command, select our sculpt as a body and the sketch as a splitting tool. When I press OK, you can now see a split line has been created, and if I go back to edit the sketch, these changes are reflected in the sculpt body. I'll repeat this for the lower shell, handle and rubber strip to create separate bodies. I'll then convert these into their own respective components by right-clicking and selecting Create Components from Body and Continue Modelling. Fusion 360's surface modelling and T-spline technologies provide a quick and efficient process for creating and refining any number of conceptual ideas. By having a unified workspace environment, products can be developed in tangency with solid modelling processes, giving you complete cohesion in your development process. Another quick tip here is you can extend a face by selecting it, then press Alt and dragging away.